All right, so in today's lesson, we're going to be talking about how to differentiate between three different kinds of function families. So we're going to be focusing on linear, exponential, and quadratic. There's actually a ton of different function families, but these tend to be three of the most important ones, both in this class as well as in the real world. So we're going to talk about several different representations of each function family. There's going to be looking at equations, looking at graphs, and looking at tables. And then as we get into our homework, we'll start looking at some real world situations and how to classify them. So when we talk about function families or types of functions, we're really kind of zoning in on different relationships that we have between the inputs and the outputs in a given situation. So first thing we're going to do is go ahead and look at an equation or the equations. So if you're dealing with a linear graph, then one clue is that your x doesn't have an exponent. So all these equations underneath are examples of linear equations. You probably are most frequently used to seeing these equations written as y equals some equation of x. But like in this third example, you can kind of have your x's and y's mixed up. As long as your x and your y both can't really have an exponent. The next type of function family is a quadratic. And one clue that you're dealing with a quadratic is that there's an x squared in the equation. And then another thing that goes along with that is that the squared has to be the biggest power of x. So there's not going to be any like x to the third powers, x to the fourth powers. The biggest thing we're going to get is an x squared. And then our third type of function family is an exponential. So when we're dealing with exponentials, our x becomes an exponent. So rather than having like an x to the second power, we're going to have something like 3 to the x power. And you'll see that in these three examples. You can also get maybe more complicated exponential by changing your exponent to like 2x or 2x plus 1. But anytime you see that x in the exponent, then that would be considered an exponential. Now, one thing to know and to be aware of is that there are going to be times in the real world where you might end up mixing some of these equations together, right? So you might end up seeing like an x squared plus 2 to the x power. This is like a combination of a quadratic and an exponential. So we couldn't really classify this equation as quadratic or exponential. It would just kind of be a combination of both. So let's go ahead and do some practice identifying whether each of these examples are linear, quadratic, or exponential. So I'm just going to go ahead and abbreviate with an L, a Q, and an E. So in number 1, we have an x as the exponent, which means it's an exponential. In number 2, we have an x to the second power and x squared in the equation, which is going to be a quadratic. Number 3, it's a linear, because you have an x that's not an exponent and there's no exponent on the x. And then in number 4, since your x is an exponent, it's going to be an exponential equation. Okay, so hopefully by now you feel comfortable identifying each equation as linear, quadratic, and exponential. Now let's jump into looking at their graphs. So here's kind of the classic shape of each of these graphs, or each of these function families. Linear makes a straight line. That one you've been dealing with for years and years. Hopefully you remember that one. A quadratic makes a parabola, which is that nice U shape. And that one, again, we spent a lot of time in Math 2, or you will spend a lot of time in Math 2, dealing with parabolas and dealing with quadratics. And then our third function family, exponentials, those look kind of like an L. And the key here is that it rises or falls quickly in one direction. So you'll kind of see this graph getting really, really steep on the left and then totally flattening out on the right. So let's take a look and classify some of these. So in A, I have a nice parabolic shape. That's going to be a quadratic. B looks a little tricky. It's just like a bunch of dots. So what we're going to think about is the trend of these dots. I'm going to kind of trace out what maybe a trend might look like. I've got that nice L looking shape. That's an exponential. And then C, since I've got a straight line, that is linear. So from the graphs, it should be a pretty quick decision of which function family each belongs to. So let's get into tables. So Our third, maybe most classic representation of a function is using a table. And this might be one of the trickiest ways to identify and to separate each of these function families. So first let's talk about linear tables. So with a linear, you're never going to see the same y value. I also have written here is that the first difference is the same. So let me show you what I mean by first difference. If you'll notice, my x values are all increasing by 1, -1, 0, 1, 2. I'm going to look at my y values and find the difference between them. So the difference between -1 and 1 is 2. Difference between 1 and 3 is 2. Difference between 3 and 5 is 2. So this 2 right here is constant. Okay, that means the first difference is constant or the same. The nice thing about that 2 is that it's also going to be the slope or the rate of change of that graph. So as I write the equation, it's going to be y equals 2 times x, because we can kind of go off y equals mx plus b, where m is the slope and b is the y-intercept. So the y-intercept is 1. It's always the value when x is equal to 0. So y equals 2x plus 1 is going to be the function equation for that table. All right, let's look at quadratics. So one way to identify a quadratic from a table, or one clue, is that you're going to see the same y value more than one time. Okay, so you can kind of have repeats in your y column. And here the second difference is the same. So let's go ahead and take a look at the second difference. So what I'm looking at is I'm looking at the difference between the two y values. So difference between 1 and 0 is 1. 1 and 0 is 1. Difference between 1 and 4 is 3. And the difference between 4 and 9 is 5. The second difference is when I start looking now at the difference between these differences that I just calculated. So the difference between 1 and 1 is 2. Between 1 and 3 is 2. And then between 3 and 5 is 2. I just realized I made one mistake. The difference between -1 and 0 is a -1. That's why the difference between -1 and 1 is -2. So this second difference is constant, which is a really important feature of this kind of graph. Okay, the next one that we want to look at is an exponential. And we're really going to zoom in on exponentials because they are very, very important for the unit that we're starting. So with exponentials, you're never going to see the same y value twice. And then there's a common multiplication pattern. So let's go ahead and take a look at what that means. So if you look at my x column, I just have the x is increased by 1 every time. 0, 1, 2, 3, 4. And I'm going to look at the multiplicative relationship between the y's. So to get from 1 to 2, I multiply by 2. To get from 2 to 4, I multiply by 2. To get from 4 to 8, I multiply by 2. To get from 8 to 16, I multiply by 2. So this would be like the common multiplication pattern. Okay? And we are going to practice writing the equation for an exponential. So an important thing here is that exponentials are always going to look something like some number b raised to the x power. Okay, that's kind of like the very simplest form of an exponential. Now, the number b, or the number that's being raised to the x power, is your common multiplication pattern. So in this case, since I'm multiplying by 2 every time, that means that 2 to the x power is going to be an important feature of this equation. Now what I need to figure out is, am I adding anything on at the end here, or am I subtracting anything from the x or from the whole equation? So I'm going to show you one way to check that. One thing that I know is that when I plug in, I can just choose any of my y and x combinations. So like, if I just look at 2, 4, if I plug in 2 for x, I should get a 4 out. And that's true, 2 squared is equal to 4, which means that I don't have to change anything else about this equation. So y equals 2 to the x is the equation that matches this table. So one of the biggest things that you'll notice is the difference between linear and quadratic and exponential is that with linear and quadratic, we were looking at like adding and subtracting differences, right? We were looking at how much do you add or how much you subtract to get to the next value of in my table. With an exponential, I'm looking at how much are you multiplying by to get to the next value of my table. And that's going to be a really important thing as we move forward. And today we're really going to focus a lot on exponentials because it really leads us into what this whole unit is about, which is logarithms.